Okay, so geometry, here's what we did. In section 2.4, reasoning with properties of algebra, it's super important that we learn this stuff because this is the intro to proofs. So first thing we did was we spoke about all the basic properties of inequalities, such as the addition property of inequality, subtraction, multiplication, and the division property. So those are all in the book. They're all ones that we have used since the beginning of algebra, and we're going to work on those. Then we went over the basics, right? The reflexive property, which says that A is always equal to A. Symmetric property, which says that if A is equal to B, then B is equal to A. And the transitive property says that if A is equal to B and B is equal to C, well then A must be equal to C. Number 8, if A is equal to B, then you are allowed to substitute A for B and B for A. And we spoke about like a soccer game. When somebody comes out, someone goes in, you're substituting one for the other there. Okay, so we had an example, we had 2 examples of algebra, right? So we tried to solve 55 x plus or minus 3. Sorry, I'm trying to figure this thing out here. Sorry. Minus 3 times the quantity 9x plus 2 or 12 equals negative 64. So the first thing we did was we wrote down the given, okay, which is above this line. Then we got to this line by saying the distributive property because we distributed the 3. Then we added 36 to both sides, so we got to here by saying the addition property of equality. Then, of course, we just simplified 5x and negative 27x, so we wrote down that we simplified that. And then we used division and said the division property of equality. So the given statements on the right-hand side, the statements on the right-hand side justify everything on the left-hand side. We had a you try and partners where they did the same sort of thing here. And I've got, what am I trying to do here? 5x minus 18 equals 3x plus 2. Oh yeah, so we have a given, and then we had the subtraction property since we took 2 away from either side. So we had the subtraction property of equality. Then again we had the subtraction property of equality because we were subtracting 5x from both sides. And then finally we had the division property and we got x equals 10. Then we had somebody else do it a different way, and they came up with the same solution of x equals 10, but they came up with different reasons on the right hand side. So there are multiple ways of doing it, just not the one way all by itself. Okay, then the last thing we did was our first proof, which we did not actually get to finish, okay? So, but I'll walk you through it right now. We were given this stuff right here, so all the stuff in the cloud. Given that A, B, and C, D are the same, how can you prove that from A all the way to C is the same thing as B all the way to D? So first what we did was we said, okay, let's let A, B equal 1. Those are the same. And then let's let B, C equal 5, all right? So we tested, is AC, so AB is 1, BC is 5, so add them together, you get 6. Is that the same thing? That's what that means. Is that the same thing as from B to D? So 1 and 5 again is 6. So it seems like this should be true, so we should be able to prove it. So we start off by saying, okay, AB is equal to AB. That was given to us. BC is equal to BC, and that's reflexive property. And then we said, well, we know that AB has to be AB plus BC is the same thing as CD plus BC, and that's the segment addition postulate. And now we know that AC was equal to AB plus BC, segment addition postulate, and BD was equal to CD plus BC, another segment addition postulate. Well, I wrote these in yellow, right? So all this stuff is in yellow, and all of this stuff is in green. And look what they're equal to. AC and BD. So the very last line, AC is equal to BD, what we were supposed to do, and that's by substitution. I'm going to go over this again tomorrow. Review tomorrow so that we all have it. Okay,